Hello everyone, in this video we're going to be discussing how to convert from polar to rectangular and from rectangular to polar. Okay, and by the way, rectangular here means Cartesian. Sometimes people call it rectangular, sometimes they call it Cartesian, so it doesn't really matter how you call it. Okay, so for complex numbers are actually divided into two categories, the Cartesian and the polar. Okay, Cartesian means x plus jy, they're in the form of x plus jy, and it's easier to do the addition and subtraction in this form. And polar is in the form of r e to the j theta, okay, which is sometimes written as r and the angle theta. Okay, and actually they're equivalent to each other, they're equal, exactly equal. And the way to convert from one to the other is that if you are given Cartesian and you'd like to convert to polar, then in that case the polar means that you need to find what the value of r and theta is. In that case, r is equal to square root of x squared plus y squared, and theta is equal to tan inverse y over x, and plus another term that I'm going to be explaining later on. Okay? Alright, if it is given in the form of a polar, so you already have the r and the theta, and you need to find the values of x and y. Then in that case you take x is equal to r cosine theta and y is equal to r sine theta. Let's take an example. We're given a complex number, 3 plus j4, and we want to convert it to a polar form. Okay? So how do I do this conversion? Then I need to calculate the value of r, which is equal to x squared plus y squared. So the square root of x squared plus y squared, which is equal to 3 squared plus 4 squared, which is equal to 5. And theta is equal to tan inverse 4, which is the y, over x, which is 3. Okay? 53.13 degrees if you do it over the calculator. Okay, what is that term for? This term is basically is added if the x is has a negative value. Okay, why is that? Because the tan inverse always yields a value between negative pi over 2 and pi over 2, between negative 90 degrees and 90 degrees. And theta might take the value from negative 180 degrees to 180 degrees. So how are we going to span this entire interval? How am I going to get values greater than this value? This is to compensate for these values. So it turns out that if the x is positive, it's always the case that theta is going to be between this range. And if x is negative, then in that case you need to add either pi or subtract pi, it doesn't really matter, to compensate for this value, to compensate and make the theta greater than 90 degrees or less than negative 90 degrees, depending on what the value of y and x are. Okay, and we're going to see an example on this. In this case, the x is positive, so that's why we did not need to do this compensation. As a matter of fact, I personally do not use this method. This is basically the unit step function. Formally, this is the way to write down theta, okay, as an equation, because if I omit it, then I'm neglecting the addition of pi, which is wrong. But I do not depend on this equation. I depend on tan inverse and compensate for the pi by looking at the x, okay? And I'm going to explain this in a moment. Let's first solve this example. If I have 3 minus j4, how do I calculate the r? Well, the r is the same, 3 squared plus negative 4 squared. Remember that this is negative 4, okay? So under the square root gives a 5. And tan inverse is equal to negative 4 over 3 inside the tan inverse, which is the arctan. How do you put this on calculator or MATLAB? This is either you use the shift tan or you use the arctan if you're using MATLAB, okay? The command is a tan, which is arctan, okay? Right? And it's going to give you the value in radians, so you need to convert it to degrees by multiplying by 180 and dividing by pi. Its value is equal to negative 53.13 degrees. So this is a positive value, this is a negative value, which means that it is counterclockwise. So this is the way you calculate theta, by going to the 0 and moving clockwise because it is negative. Okay, and this is 3 minus 4 as a point. Okay, and that's basically why theta is equal to a negative value. Alright, let's move on to another example. Negative 3 plus j4. Again, r is not different, but theta here is different. Its value is negative 53.13 because that's the value of tan inverse, but you need to compensate for theta. Previously I did, you need to compensate for the pi. Okay, why? Because the x is negative. Previously I did not do this because the x was positive. And the law and the rule says that if x is negative, then in that case add a pi. If x is not negative, then do not do anything. Right? So here x is not negative, so I'm not doing anything. Right? Here x is negative, so I need to add a pi. So that's why this is equal to negative 53.13 plus pi, which is 180 degrees, which gives us 126.87. Okay? If you did not add this pi, then in that case you're going to get this angle. Although in reality, this is negative 3 plus j4. So that point is negative 3 and 4. Alright? And this is 3 and negative 4. Obviously their angles are not equal, but they're different by 180 degrees. So that's why you need to compensate for this 180 degrees and get the correct theta. Right? I added here 180 degrees. But in this example, I'm going to subtract 180 degrees for a particular reason that I'm going to discuss. Let me present the example. The example says that we have a negative 3 minus j4. The r is equal to 5. Theta is equal to 53.13 because the negatives are cancel each other. And this is not the correct value theta that I'm looking for. Why? Because the x is a negative value. And that's why we need to compensate for theta. 53.13 degrees. And here I'm going to subtract 180 degrees. I'm not going to add. Adding or subtracting, it doesn't matter. Why? Because if you have a particular theta, okay, which is a certain value, let's assume that it is phi, okay, that's an angle, and you add 360 degrees to this angle, or subtract 360 degrees from that angle, it doesn't really matter. Okay, so if you made a mistake and made an addition, you can still subtract 360 degrees. It doesn't really matter. So why did I choose to subtract 180 degrees? Because I prefer theta to be between negative pi and pi. Because this is the convention, for theta to be between negative 180 and 180. If I added 180, then it's going to exceed this value. It's going to exceed 180, which is not the convention. Right? So I get 133.13 degrees. Okay, let's take another example. In this example, we have two polar forms, and we would like to convert them to Cartesian. Why do I want to convert them to Cartesian? Because the question is asking me to add. If I'm adding, then it's much easier to do the addition in the Cartesian form, in the rectangular form. Let's convert this to Cartesian, and let's convert this to a Cartesian, and then do the addition. Okay? How am I going to convert to Cartesian? I need to first find the value of x and the value of y. Multiply x by 1, multiply the y by j, and then add them. And this becomes the first number. And the second number, you do the same thing as well. Okay? So that's the x. How did I get the x? The rule says x equals to r cosine theta. Let's have a look at r. R here is 5. Theta is pi over 3. So 5 cosine pi over 3. And here 5 sine pi over 3. That's the value of the y. And the same goes for the other number. right? If you do the math and add them, how are we going to add them? I'm going to add the real plus the real and the imaginary plus the imaginary. The imaginary turns out to cancel each other. Why are they canceling each other? Because this value is exactly equal to this value. Why? Because they're conjugates. How did I know that they're conjugates? The theta is equal to the negative of the theta, and the amplitudes are the same. That's how I know that these numbers are conjugates. Okay, and that is why they turn out to cancel each other, and thus the value, the final answer becomes twice the real part. Okay, and that's why I could have from the beginning noticed this and did not do this all of these steps. I just calculate the real part, which is the x, right? And in that case, the real part, which is the x, is 5 cosine pi over 3, and then multiplied by 2. Twice the real part of that number is going to give us the value of the final answer. Okay? And the same goes for that example as well. If I have a subtraction, if I have an addition, then in that case, a plus bj, that's a complex number, plus a minus bj, that's the conjugate of that complex number, gives us twice the real part. If it's a subtraction, then it is going to be twice the imaginary part multiplied by j. Twice the imaginary part multiplied by j. Okay? So that's why if I'm giving you two complex numbers, and you have noticed that these two complex numbers are complex conjugate. Why? Because every j is replaced with a negative j. That's a j, and this is negative j. And there is a subtraction between these two numbers. Then I take twice the imaginary part and multiply by j. Okay? How did I get the imaginary part? The imaginary part is equal to that number, right? The amplitude multiplied by the sine of the theta. That's the imaginary. The rule says that the imaginary part, which is the y, is r sine theta. The amplitude multiplied by sine theta. Okay, let's get the amplitude and then multiplied by sine theta. Okay, here I have two numbers, right? I have two numbers. Let's first calculate the amplitude of the first one. How do I calculate this amplitude? The amplitude is equal to 1 over the square root of 4. How did I know this? Well, the amplitude of that number is 1 over the amplitude of the denominator. That's a fact. That's a property of complex numbers. If you have 1 over z, then in that case, and you want to calculate the amplitude, okay, then it's equal to 1 over the amplitude of z. Okay, so I need right now to calculate the amplitude of this number, which is in the denominator, which is going to be the squaring of the first, the squaring of the second under the square root. 1 squared plus square root of 3 squared. Okay, so that's basically how you calculate the amplitude. Okay, and that's the phase. All right, the phase is equal to is equal to tan inverse square root of y over x, and then you put a negative sign because we wanted to convert this from the denominator to the numerator. Okay, if I want the phase of 1 over z, then is equal to negative the phase of z. Okay, 1 over z is equal to negative the phase of z. Okay, all right, so that's the negative multiplied by negative tan inverse square root of 3 over 1, and then you multiply by that number. Okay, that's a number, and this is a complex number. All of these are phases. If you want to calculate the imaginary, how do you get the imaginary? You get the amplitude, right, which is pi which is 1 over, you get the amplitude, which is 1 over 4, 1 over square root, that's basically equal to 1 over 2, and multiplied by sine the angle. How do you get the angle? The angle is this angle plus that angle. So pi over 4 plus negative 10 inverse square root of 3, okay, under the sine. And here I have 2 over 2, which gives us 1. And the 2 in the numerator coming from that 2 in the denominator coming from the half. Okay, so this becomes the final answer. Okay, let's look at another example. This other example, it says that 1 over that number and 1 over that number, and it tells me that it is a complex conjugate. How did I know? This is j, this is negative j, j and negative j. But here it's a t. It's in terms of t. How do I do the calculation? How do I calculate the z? I need to first find the amplitude and find the phase. You could still do the math, right, and convert them by step, right? But it's going to take a lot of time. So that's why I applied the formula over here, and the formula is by doing by this shortcut, okay, which is pi over 4, that's the phase, multiplied by t, okay, and this is coming from that number, okay, or this number in particular, minus 10 inverse square root of 3 coming from this phase, okay, and this becomes the final answer, right? And this final answer is in terms of t. I cannot do calculation, I cannot simplify it any further, right? This document is mentioned in the notes. This note is mentioned in the description of the video, and the Arabic version of this video is mentioned in the description as well. Make sure to share this video if you found it useful. Most likely other people need it as well. Thank you.